Hi everyone. Let's start IGCSE O levels paper 4 theory, February March 2025, variance 42. The duration of this paper is 1 hour 15 minutes. Obviously जो Cambridge examination का होगा उसमें आपको 1 hour 45 minutes मिलते हैं, ठीक है? Let's see what we have in the question number 1. Using numbers only, state the percentage of oxygen in clean dry air. So according to the lecture, oxygen has 21% in the air. Next, typical operating temperature in degrees Celsius used in Haber's process is going to be 450 degrees Celsius. Number of atoms in a diatomic molecule. By the way, diatomic molecule consists of 2 atoms. So number of atoms basically 2. Maximum number of electrons in the second electron shell of an atom. Second electron is basically L shell, and L shell contain maximum 8 electrons. Now the next is number of hydrogen atoms in an alkane with 7 carbon atoms. See, let's apply the general formula of alkane here, CnH2n plus 2. We have 7 carbon atom, so 2 into 7 plus 2. So it's going to be 2C7 at 16. So hydrogen is going to be 16. Okay. Number of particles in 1 mole in the standard form, 6.02 times 10 to the power 23. Now question number 2. This question is about ionic compounds. Ionic compounds exhibit ionic bonding and they have a giant crystal lattice structure. What is meant by the term ionic bond? Ionic bond is basically an electrostatic attraction between cation and anion all right. Potassium sulfide K2S is an ionic compound. Complete the dot and cross diagram in figure 2.1, ions in the potassium sulfide. Now potassium has a plus charge and potassium has an atomic number of 19, which means it has 2 electrons in the first shell, 8 electrons in the second shell, and 8 electrons in the third shell, and 1 electron in the last shell. So when positive charge appears, which means 1 electron is lost from the valence shell, so I need to mention this valence electron also. So this is 2, this is 4, this is 6, and this one is 8. So that's potassium ion. Let's talk about sulfur. Sulfur has an atomic number of 16. Let's configure it. First shell में 2, second shell contain 8, and third shell contains 6 electrons. All right. So third shell has 6 electrons. So let me show the third shell. Now this shell has 6 electrons. 1, 2, 3, 4, 5, and this one is 6. Okay. Now potassium contain 8 electrons in the third shell. 2, 4, 6, and this one is 8. So this potassium lost 1 electron from its valence shell. So इस potassium का 1 electron transfer होकर sulfur में आएगा. इस potassium का भी 1 electron transfer होकर sulfur gain करेगा. तो sulfur technically gain 1 electron from each potassium atom, and therefore this sulfur carries 2 negative charge because it gains 2 electron in its valence shell. So the whole diagram of potassium sulfide. I hope it makes sense to you. Next, ionic compounds forms giant ionic lattices. Shows part of the giant ionic lattice structure of sodium chloride. We did that in class. We did sodium chloride lattice. Complete the diagram to show the ions present. Use positive for sodium ion and negative for chloride ion. One chloride ion has been completed for you. Okay. So this is sodium ion. This is chloride ion. This is sodium ion. This is chloride ion. This is sodium ion. This is chloride ion. This is sodium ion. All right. So make sure that you need to mention opposite charges, so that they can have an experience of electrostatic attraction between them. Two similar charges, either positive or negative, will repel each other. So make sure that plus minus interact करें आपस में. Two positive interact ना करें, two negative interact ना करें. Give the name given to any positive ion. That's cation actually, because positive ion is also called cation. Ionic compounds can be decomposed by the passage of an electric current, and that's called electrolysis. So name the process, electrolysis. Write ionic half equation for the reaction which takes place at the anode. By the way, anode is attached to the positive terminal of the battery, and obviously at anode oxidation takes place. When molten potassium bromide is decomposed by the passage of an electric current. So obviously bromide ion discharge at anode in the form of bromine gas. When bromine exists in diatomic molecules, so in order to balance the equation, we need to mention 2 here and 2 here also. Okay. An examiner is looking for the ionic half equation. So examiner doesn't require any state symbol here, so we can ignore it. Okay. Name the products and state the observations at the negative and positive electrode when dilute aqueous potassium bromide is decomposed by the passage of an electric current. See, we have potassium ions and hydrogen ions and hydroxide ions and bromide ions. We know that hydrogen ion is closer to the line of discharge, which is why it will move first from the electrolyte in the form of hydrogen gas at cathode. Similarly, hydroxide ion is closer to the line of discharge, so it will move first from the electrolyte in the form of oxygen gas at anode. That's what we have done in the class. That is the concept we have given you. So negative electrode is technically cathode. Cathode is attached to the negative terminal of the battery, which is why it is also called negative electrode. So product at negative electrode is hydrogen. Gas. Observation at negative electrode, colorless, odorless, bubbles of gas. See guys, positive electrode is technically anode. Okay. And at anode, we have oxygen gas. An examiner is looking for the two products at anode, which means first oxygen gas is given out, and after the removal of all hydroxide ions, bromide ions will discharge at anode as well in the form of bromine. Observation at the positive electrode, obviously bromine is red brown. and oxygen is colorless, odorless, bubbles. So that's the end of this question number 2. Okay. So that's very important aspect of the question, because first hydroxide ion discharge at anode in the form of oxygen gas, that will show you colorless, odorless bubbles of gas. And after the removal of all hydroxide ions, still bromide ion present in the electrolyte, so they will discharge at anode in the form of bromine. So bromine shows red brown color or orange color. Okay. यहाँ पर अगर सिर्फ एक ही एम्प्टी स्पेस होती तो मैं ऑक्सीजन गैस को प्रायोरिटी देता, मैं ब्रोमीन को प्रायोरिटी नहीं देता. सिंस वी हैव टू डैशेस, टू ब्लैंक्स स्पेसेस, व्हिच इज व्हाई मैंने दोनों को लिखा है. ओके. The halogens are a group of elements in the periodic table. Halogens belongs to group 17 of the periodic table. I mean to say group 7. Okay. Chlorine is a member of this group. State the group number of the halogen, group 7. And always remember, group is always represented by Roman numerals, while period number is always represented by English numerals, right? State how many halogens there are in this group. So you should remember the entire group. The first one is fluorine, chlorine, bromine, iodine, and then astatine. So how many we have? 1, 2, 3, 4, 5. 5 group. Suggest the identity of the halogen which has the highest density. So higher the MR, higher the density. So astatine has the highest density because its MR is the highest. See, density is always equals to mass per unit volume. So if mass is higher, density is also higher. If volume is lower, density becomes higher, right? Since halogen has a higher molecular mass, so its density is also higher. I hope it makes sense to you. Is the most reactive. Fluorine is the most reactive. State the name of the negative ions formed by the halogens. I've told you in the class, halide ions. I've told you in the class that fluorite, chlorite, bromide, iodide, and astatite are generally called halides, and all halides are generally represented by X negative sign or X negative symbol. State how many occupied electron shells there are in a bromine atom. So fluorine is found in period 2, chlorine is found in period 3, bromine is found in period 4. Since it is found in period 4, which means we have total 4 shells in bromine molecule. Okay. So period number is basically the number of shell. Name the noble gas which has the same electronic configuration as bromide. Since bromide has 8, bromine has a bromine has an atomic number of 35 and it has a negative charge, which means in total we have 36 electrons. So let me check which noble gas has total 36 electrons. Let me check from the periodic table. 36. Krypton has an atomic number of 36, which means krypton is going to be the right answer. Okay. Aqueous chlorine, basically chlorine is an oxidizing agent. Oxidizing agent. reacts with aqueous potassium iodide. So we have told you in the class that potassium iodide is a reducing agent, which means when they will react together, redox reaction takes place. One of the product form is iodine, all right. Complete and balance the ionic equation for the reaction between chlorine and iodide ions. State symbols are not required. When chlorine is an oxidizing agent, so it oxidizes iodide into iodine, and obviously khud reduce ho jayega. When it reduces itself, it will turn to chloride ion. How many iodine here? 2. So put 2 here. How many chlorine here? 2. So put 2 here. So that's a balanced chemical equation, okay? And we have done this sort of ionic equation in the class in group 7 elements. Explain why this reaction is defined as a redox reaction. Give your answer in terms of electron transfer. See, chlorine has an oxidation state 0 in chlorine molecule. It has an oxidation state of -1. So technically, decrease in oxidation state is reduction, and it undergoes reduction because during the reaction it gains electron, whereas iodide ions loses electron and converted into iodine atom because during the reaction it will oxidize, okay, because of the increase in oxidation state. So chlorine molecule undergoes reduction, iodide ions undergoes oxidation. So chlorine molecule undergoes reduction due to gain of electron, and iodide ions undergoes oxidation due to loss of electron. Give the color and state of iodine at room temperature and pressure. At RTP, it is solid and its color is black. That's the end of third question. Let's move on to the fourth one. Carbonyl chloride COCl2 is manufactured by reacting carbon monoxide with chlorine. By the way, forward reaction is exothermic. Reaction is exothermic because enthalpy change is negative. This process takes place in a closed system, and obviously closed system hai to reversible reaction hoga, which is represented by double-headed arrow, and the equilibrium is reached. The conditions for this process is 200 degrees Celsius and 200 kilopascal pressure. Explain what is mean by the term closed system. When reaction takes place in a closed container or closed vessel. Next, state what the symbol delta H represent. This delta is change and H is enthalpy. So obviously it's going to be enthalpy change. State how the value of delta H shows that the forward reaction is exothermic, because delta H for forward reaction is negative. Deduce the value of delta H for the reverse reaction, include a sign in your answer. So if forward reaction is exothermic, obviously reverse reaction is endothermic. If reverse reaction is endothermic, so obviously it's going to be plus 105 kilojoule per mole, okay? Because reverse reaction is endothermic. So energy value remains same, just we need to flip the sign. Yeah. Complete table 4.1 to show the effect, if any, on the concentration of COCl2 at equilibrium when the following changes to the conditions are applied. Use only the words increases, decreases, or no change. The temperature is increased, effect on the concentration of COCl2 at equilibrium. So if you increase the temperature in any exothermic reaction, equilibrium always favors towards left-hand side, and obviously the concentration of COCl2 decreases according to Lee-Schecter's principle. Some carbon monoxide is added. So if I'll add carbon monoxide, obviously the concentration of CO increases. This favors the equilibrium towards right-hand side, and obviously COCl2 concentration increases. Now let's talk about the increase in pressure. So pressure के लिए we need to determine the moles of reactants and products. Both of them are gaseous, exist in gaseous states, so we need to calculate the number of moles. So total moles on the reactant side is 2. Total moles on the product side is 1. So if you increase the pressure, equilibrium favors in that direction where we can have less number of moles, which is why, according to Lee-Schecter's principle, equilibrium favors towards right-hand side, towards the product side. So the concentration of COCl2 increases. Catalyst is added. So catalyst increases the rate of forward and rate of backward reaction. Catalyst never increases the concentration of COCl2. So no change in this particular condition. Okay. So catalyst increases only rate of reaction, no impact on the equilibrium yield and so concentration. Okay. Part F. The equation for the reaction can be represented as shown in figure 4.1. By the way, forward reaction is exothermic. Let me copy this equation. So examiner has given us some bond energy data values, and examiner is looking for the bond energy of carbon double bond oxygen bond. All right. And the delta H value is also given. Use the following steps. Calculate the energy needed to break all the bond in the reactant. So that's easy. So energy to break the bonds, which means we need to check the reactants things. And in reactants, we have carbon monoxide, which contain triple bond. Its bond energy value is 1075. We have chlorine molecule. Its bond energy is 240. So if we add these two values, I'll get what? 1315. Okay. So it's going to be 1315. So 1315 kilojoule energy is used to break these bonds in the reactants. Okay. Calculate the energy released when the bonds in carbonyl chloride forms. When we say energy released, then it means we need to check the products. Because during the formation of products, new bonds are formed, and the formation of new bonds is basically an exothermic process, which is why we need to consider product here. And in product, we have this molecule. Okay. So this molecule has 2 carbon chlorine bond and 1 carbon double bond oxygen bond. So carbon chlorine has a bond energy of 340. We need to multiply by 2 because we have 2 bonds. So energy is going to be how much? 340 into 2 is going to be 680. And we need to determine this energy of this bond. So for C double bond O, I'll use X because I need to find out the energy of this. So total energy of this is basically 680 plus X. And we need to find out the bond energy in the next part. So I'm going to apply the formula delta H equals to enthalpy of reactant minus enthalpy of product. Delta H is already given in the question, which is minus 105. Reactant is 1315 minus product is 680 plus X. So it's basically minus 105 equals to 1315 minus 680 is going to be 635 plus X. Then X equals to 740. So minus 740 minus 105 equals to 630. Hold on, 635 minus 680. 1315 minus 680, 635. So 635 minus 105 is going to be 530. So 530 plus 530. Kilojoules per mole. Can you guys plus check? 530 is the right answer. 1315 minus 680, 635. Hmm. Six 35 minus 105 is going to be 530 plus. Okay, that's my answer. I hope it makes sense to you. Next, complete the dot and cross diagram in figure 4.2 of a molecule of carbonyl chloride. Show outer shell electrons. First thing, carbon has 4 valence electrons. Second thing, chlorine has 7 valence electrons. Third, oxygen has 2 valence electrons. Sorry, 6. And one more thing, we need to remember this diagram also so that we can, distribute the number of electrons according to this diagram. That's going to be easier for us. That this diagram shows that carbon and chlorine has single covalent bond, which means 1 electron of each element shared together. So carbon has 4 valence electrons. 1, 2, 3, and this one is 4. And oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. Now chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Same here. 1, 2, 3, 4, 5, 6, and this one is 7. Okay, so that's the end of this question. Let's move on to the next one. Question number 5. Manganese is the element with atomic number 25 in the periodic table. Manganese is basically the transition element which has an atomic number of 25. Calcium is found in group 2 of the periodic table and it has an atomic number of 20. Complete table 5.1 to show the number of protons, neutrons, and electrons in manganese atom and calcium 2 plus ion. So manganese has an atomic number of 25 and its mass number is 55. So it has 25 proton, 25 electron, and 55 minus 25 becomes 30 neutron. So let me arrange this. 25 protons because proton number is 25. Electron is 25 because it is neutral, it has no charge. And neutron is going to be 30 because 55 minus 30 becomes, or 55 minus 25 becomes 30. All right. So let's talk about calcium here. Calcium has an atomic number of 20 and its mass is technically 42. So it has 20 protons, 20 electrons, and technically 42 minus 20 becomes 22 neutrons. Okay. Problem is number of protons will remain same because protons are found in the nucleus. Number of neutron will remain same. I mean, there is no change in the neutron number because they are found in the nucleus also. But since calcium has 2 plus charge, which means 2 electron is lost. So if we have total 20 electrons and 2 electrons lost, obviously 18 electrons are left in the calcium ion. I hope it makes sense to you. That's an easy piece of information. Manganese forms several oxides. The formulae of some of these oxides are shown. Suggest why manganese is expected to form colored compounds, because manganese is a transition element. State which other property of manganese is shown by the formation of several oxides. Technically, transition elements have variable oxidation states. So look at these oxides. Over here we have +2. Over here we have +3, +4. What was the 8? This is +5. This is +4, and this is, I believe, 7 to the 4 +7. Okay, so they have shown different oxidation state. So I think it's, let me calculate. X minus 2 equals to 0. Then x equals to +2. Then 2x minus 6 equals to 0. Then x equals to +3. Then 3x minus 8 equals to 0. Then x equals to 4 times 2, 8. And 8 divided by 3 is going to be 2.66. Okay, that's the fraction value. You can ignore that. MnO2 x minus 4 equals to 0. Then x equals to +4. And then 2x minus 7 to the 14 equals to 0. Then x equals to +7. Now, except this, look at these values. They have variable oxidation state, which is why they can form different oxides. Because they have variable oxidation state. State the formula of manganese 2 oxide. Manganese 2 oxide is basically MnO. Mn3O4 is found in an ore of manganese. Manganese metal can be extracted from this ore using aluminum as the reducing agent. Define the term reducing agent. We have discussed reducing agent in the class. Reducing agent दूसरे कंपाउंड को रिड्यूस करते हैं, खुद ऑक्सीडाइज होते हैं. जब खुद ऑक्सीडाइज होते हैं तो इलेक्ट्रॉन लूज करते हैं. सो रिड्यूसिंग एजेंट किस तरह से देखिए, substances which causes another substance to be reduced and oxidizes themselves, which means during the reaction they will lose electron. Complete the symbol equation by inserting the formula of the missing products and balancing equation. Ooh. Obviously, aluminum and oxygen combine together to give aluminum oxide. How many manganese here? 3. Put 3 here. How many oxygen atom here? 4. So put 4 here. How many aluminum so far? 4 times 2, 8. Put 8 here. And obviously I'll use 1 here. So that's the balanced chemical equation. Okay, let's move on to the next part. MnO2 reacts with dilute hydrochloric acid as shown in the equation. Calculate the volume of chlorine gas formed in cm cube at RTP. So we are looking for the volume of chlorine gas. And obviously we can find it if 50 cm cube of 0.2 mole per dm cube HCl is given. All right. So first of all, let me find out the moles of HCl. That's easy. Piece of cake. 1000 cm cube of HCl contain 0.200 mole. Okay. So if we have 50 cm cube, okay. If we have 50 cm cube of HCl, moles would be 0.200 into 50 divided by 1000. So it's going to be 0.01 mole. Okay. Now, according to the equation, we have 4 moles of HCl and 1 mole of chlorine. So I'm going to take the molar ratio between HCl and chlorine. So 4 moles of HCl gives 1 mole of chlorine. When we have 0.01 moles of HCl, so moles of chlorine would be 2.5 into 10 to the power minus 3. We need to find out the volume. So to calculate the volume of chlorine, moles needs to multiply with molar volume in cm cube. So I'm going to use 24,000 cm cube straight away. Multiply 24,000. So I'll get 60 cm cube. Okay. Let me check my calculation. बेटा जब भी calculation करें one time उसको check जरूर करें, ठीक है? Yeah, that's fine. Describe a test for chlorine gas. Combines with litmus paper, observation, bleaches, blue litmus paper. Explain in terms of collision theory why decreasing the temperature decreases the rate of this reaction. When temperature decreases, kinetic energy decreases. Kinetic energy decreases, movement of molecule decreases. Movement of molecule decreases. Obviously, frequent collision between the molecule decreases. As a result, effective collision in a unit time decreases, and therefore rate of reaction decreases. All right. So as temperature decreases, so if temperature decreases, obviously kinetic energy of the molecule decreases. Movement of molecules slows down. Frequent collision between molecules decreases. So collision frequency decreases. Hence, rate of reaction decreases. Okay. That's a very lengthy question. This question has 17 marks, guys. Okay. Let's move on to the question number 16 or question number 6. The structural formulae of the two compounds A and B are shown. Okay. A and B are members of the same homologous series. By the way, this is an alkene. This is also an alkene. This is propene. This is butene. Okay. Both of them are unsaturated hydrocarbon because they contain double bond between the carbon atom. So give two reasons why structural formulae A and B show they are members of the same homologous series, because they have same functional group. And so they can have same chemical properties. Also, they can have same general formula. So 3 में से कोई 2 लिख दीजिए. So they have same general formula. Explain why A and B are both hydrocarbons. Because they consist of carbon and hydrogen only. Write the symbol equation for the completing combustion of A. The formula for this compound is basically C3H6. And the molecular formula of this compound is basically C4H8. So examiner is looking for compound A, so it's C3H6. Complete combustion examiner is talking about, so we need oxygen converting into carbon dioxide and obviously water. So let's check how many oxygen we have on the product side. 3 times 2, 6, 6 plus 3, 9. So it's basically 9 by 2. Okay, or even you can write you can multiply the entire equation by 2 also. Okay, that's also acceptable, and this fraction value equation is also acceptable in the paper. Deduce the empirical formula of A. Empirical formula. See, its molecular formula is C3H6. I can halve the number of hydrogen atom, but I can't halve the number of carbon atom, right? Since we cannot halve the carbon atom, which means जो molecular formula है वही empirical formula होगा. So it's going to be C3. Hold on. One more thing. C3H6 divided by 3. So it's CH3, I believe, right? To get the simplest ratio, I can get it. Yeah, CH3. Or C3H6 also. Okay. Both are acceptable in the paper. Name compound B. Butene. Also called 2-butene. A structural isomer of B is a member of the same homologous series. Draw the displayed formula of this structural isomer of B. We have discussed this thing in the class. I've given you a couple of examples. The most common one is butanene. And in class, we have discussed 2-methylpropene also, all right? So I'm going to make butanene because it is one of the most easiest isomer. And examiner is looking for the displayed formula, which means we need to mention all the bonds and all the atoms. So it's CH3, CH2, CH double bond, CH2. That's butanene, all right? And butanene is basically the isomer of butene, okay? Compound B reacts with aqueous bromine at room temperature to form product C. The equation is shown. When butene reacts with bromine, you will get this product. And I've discussed this thing in the class. You can check the notes, okay? Suggest why this is the addition reaction, because only one product is formed. Describe the color change in aqueous bromine during this reaction from orange or red brown also. From orange to colorless or red brown to colorless. Name product C. Let me write this structure. CH3, CH, Br, CH, Br, and this is CH3. So what I've told you in the class, whenever you get the compound, first of all, you need to, numbering the carbon atom, all right? So this is first carbon, this is second, this is third, and this is fourth. Now from the right hand side, bromine comes on second and third carbon atom. If I'll do the numbering from the left hand side, let me check 1, 2, 3, and 4. जब हमने लेफ्ट हैंड साइड से किया तो ब्रोमीन कम्स ऑन सेकंड एंड थर्ड, क्योंकि दोनों की पोजीशन सेम आ रही है तो नेमिंग के लिए किसी भी साइड को ले सकते हैं. सो सेकंड पे ब्रोमीन है, थर्ड पे ब्रोमीन है, तो इट्स बेसिकली 2,3 dash dibromo. So second and third carbon atom have bromine and 2 bromines, so it's dibromo. Second and third carbon पे 2,3 dash dibromo, and 4 carbon atom is called butane. So compound का नाम is 2,3 dash dibromo butane. And why butane? Because all of them are single bonded carbon atom, saturated hydrocarbon. Okay. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid. Carboxylic acid D has 2 carbon atoms. Draw the displayed formula of carboxylic acid D. 1 mole of B reacts with oxygen. It gives 2 moles of carboxylic acid. Oh my goodness. This is butene, an examiner is converting this compound into a carboxylic acid, and that carboxylic acid contain only 2 carbon atoms. So 2 carbon ka carboxylic acid is called ethanoic acid. Okay. So when you, and by the way, one more thing. In class, I've told you that oxygen is basically an oxidizing agent also, which means this reaction is going to be the oxidation reaction. And 2 moles of carboxylic acid are formed. Oh my goodness. So 2 carboxylic acids are formed, which contain 2 carbon atom only. And oxygen, by the way, is an oxidizing agent. So what I'm going to do is CH3 will remain as it is. Okay. This CH3 will remain as it is. This CH will turn to COH. So that's your ethanoic acid, by the way, which contain 2 carbon atoms. Plus. This CH3 will remain as it is. And this CH will turn to COH. Again, this is ethanoic acid, which contain only 2 carbon atoms. So 2 moles of ethanoic acid is formed. This is D, and this is D. So instead of writing like this, आप इसको इस तरह से भी तो लिख सकते हो. 2 moles of ethanoic acid. ऐसे भी तो लिख सकते हो. एग्जामिनर ये तो कह रहा है 2 moles of ethanoic acid है. बट मुझे लगता है कि जैसे मैंने लिखा था वैसे ही लिखे, बिकॉज वो आपको अंडरस्टैंडिंग में ज्यादा बेहतर लगेगा. Okay, name the carboxylic acid D, ethanoic acid. That's a very tricky part of the question. That's not an easy thing. And you know what? That's not given in the syllabus also. But examiner is asking because he has given you the entire instructions. An examiner is not looking for the balanced chemical equation also. He just wanted you to write the correct structure of carboxylic acid. Simple. Oh, give the complete symbol equation for this reaction. My goodness. O2. 2 moles of ethanoic acid. Okay, let me check how many carbon atoms here. 1, 2, 3, 4. And how many carbon atoms here? 4. So carbon balanced. How many hydrogen atoms? 8. How many hydrogen atoms? 2 times 3, 6. 6 plus 2, 8. How many oxygen atom? 2. How many oxygen atom? 2. It's balanced chemical equation. This balanced chemical equation also. So that's the end of this paper, guys. I hope it makes sense to you. By the way, last part of the question paper is really, really my favorite. That's an amazing piece of question.